Welcome back, guys. So today my topic is very simple, that is properties of electric field lines. First of all, what is electric field? Electric field is the region. It is the region surrounded by charge. It is the region surrounded by charge where other charges experiences force. Where other charges experiences force. Other charged particle experiences force. Experiences force by this charge. That region is called electric field. So here example, positive Q charge bond is there and a negative charge body. So around this there is some region. Depends on the charge. There is a other charge experiences the force. So that region is called electric field. So electric field is defined as force on charge by Q or F equal to E. That means force and E are parallel vectors. Force and field are parallel vectors. If the charge is positive, the force is along the field direction. So this is uniform field considered. Means field lines are equal distance and parallel. So the charge is placed in the field. The force on the charge is along the field one because these two are parallel. If negative charge is placed in the field, the force is opposite to the field direction. And if charge is positive, means charged body is positive, the field around this is at away. So the field lines represents. So here these field lines are representing the field around this body, in which direction they exist. So these lines are not physically exist. So to explain the nature, so the field lines, there is no physical existence for the field lines. So for knowing the properties and the nature of these field lines around the charged body, we are taking like this. If the charged body is positive, the field lines are away and moving away from the body. And if charged body is negative, the field lines are towards the body. So like in the magnetic field, the same. In magnet, around the magnet, magnetic field lines are away from the north pole and inward the south pole, toward the south. The same way like this. And we can say magnet and these charges are compared means negative charge behave like south pole and positive charge body behave like north pole of the cycles. And the field around the charged body is existing side lines. Field lines are straight lines. They never intersect. They could not form the loops. They never intersect, because if they are intersect, at the point of intersecting, the field should exist in two directions, so which is absurd. So that is the reason they will not never intersect. And if we see here, the field lines are in one place, in one area, they are nearer, and another area, they are another place, they are far. Means separation, suppers. That means where they are close, very close, that place we can say the field is strong field, and where the field lines are separating, that place or that area you can say is field is less. So number of field lines are same through cross section. That number of field lines through the cross section area is called flux, that we'll discuss in another topic, flux topic. So if you see here, to this cross section area, field lines are 4, and here the same cross section area consider here, the field lines are not 4 lines, it is away from this cross section area, so less. So here flux is less, here flux is more, but area is same. So we can say field is also more at where the field lines are nearer and less at the field lines are separated. So this is about properties of field lines. So next, equilibrium or null point. So equilibrium means where force is 0 or field is 0 point. To become field is 0, that means field at the point net field should be 0. Net field will be 0. So net field means there are number of fields are there. Vector sum of those fields is equal to 0. So suppose I am taking only two charges here. Two system of charges are two. One is Q1 and another one is Q2. Their magnitudes are different, but nature is same. Positive and positive. Similar charges, like charges I have considered. So when like charges are there, the null point lies between them. Means, so for example, consider here one unit charge. Unit charge is always 1 coulomb. So unit charge in the x distance from Q1. So we know on the Q1 the field will be in the direction of force. So force, we know repulsive force acting away and field also acting in this direction. Similarly, E2 opposite direction. These two are equal in magnitude and opposite direction. Then that sum will become 0. E1 plus E2 is equal to 0. It means from the Q1, this unit charge means unit charge which is experiencing the net field is 0 by these two charges in x distance from Q1, then R minus x distance from Q2. Therefore, from the field formula, field is equal to F by Q, that equal to K Q1 Q2 by R square or x square. So here Q1 and this is Q2 is only one test charge, means field on Q I am going to find out that test charge is 1 coulomb. So I will apply here Q1. K Q1 by x square is equal to K Q2 by R minus x whole square. This is the field equation. So from this x value is equal to r by root over q2 by q1 plus 1. Root over q2 by q1. Root is only for q2 by q1. And here q1 equal to q2 means these two charges are equal and similar. Same charge. That means plus similar charges. Then the null point distance is equal. X equal to r by 2 and r minus x is also r by 2 only. Between lies between the midpoint when q1 and q2 are equal. If we see here q1 is less. Q1 is less means this total value will become root value will become more. So this will become more means this total denominator will become more, x will be less. Therefore, we can say here the null point lies near the heavier charge. When two charges are not equal in magnitude and they are similar charges, then if Q1 is greater, so this total value is less. Q1 is greater, this total value is less. Root over Q2 by Q1. So this total value is less means 1 plus less value. This also will become less value only. Then x will be more than. That means it is r by 2. More than r by. So it will be nearer Q2. Means Q1 is less means Q2 is more automatically. Therefore, lies nearer the heavier charge. If reverse process means opposite or converse of this phenomena, first phenomena, consider there is a two unlike charges. One is Q2 and another one is Q1, and Q1 is less than Q2 or Q2 greater than Q2. Means their magnitudes are not equal, but their charges are different, unlike charges. In this case, the null point is not between the Q1 and Q2 charges. Either it is Q1 side, left of the Q1 or right of the Q2. So if you take the forces on Q, this left side by Q1, so it will be attractive force this direction, and by Q2 it is repulsive force and repulsive field will be this direction. Field cannot be attractive or repulsive. Field is always away from the charge. For considering the charge, it is away. So here these two fields are equal. The force on charge is field, therefore force only consider here. Force direction is easy, attractive and repulsive. So these two forces due to this on the charge by Q1 and Q2 are acting as on figure here arrow marks. So these two are equal means net force is 0 and net field also 0. So here and force 0 means fields no need to be may 0, may not be 0. That I will explain in electric field due to solid sphere and hollow sphere. There I will come to explain. So yeah, in this system of charges, in this case I can consider force also. Coming into here at this point, right hand side of the positive Q2, which side is lies will tell condition later. Now, for example, the Q means null point is here, it lies means. So it is correct or not check. Because of Q2 on this one, it will be in the direction. Because of Q by Q1 attracting force in the direction. This is F1 and F2. So these two can be equal, opposite direction. If equal means the net field on this Q will be 0. And the same way, if these two are forces on the charge, so if these two are equal forces means the field on the charge by Q1 and Q2 also can be 0. So when this point lies left side or right side. So that depends on the magnitude I said already. So if Q1 is less, then null point near the Q1. If Q2 is less, null point near the Q2. It not depends on the sign. Very, very important. It not depends on the sign. It depends only on the magnitude. So the null point from the Q1, this is the x I have considered for explanation. Q1 by x square equal to Q2 by, if from the Q1 x distance, from Q2 it is r plus x distance. So r plus x whole square. By solving this, I will get x equal to r by root over Q2 by Q1 minus 1. So this is null point calculation from any one charge, means Q1 charge. Then Q2 charge means r plus x plus r, you can add this, you will get some other answer. And here r minus x from Q2. So this is calculation of null point or equilibrium point in the electric field. So this is about electric field properties and the null point concept. The field due to ring, solid sphere, charge sheet, infinite charge sheet, and some related cases I will explain in the next class. Thank you all.